Swayam Prabha. Digital India. Educated India.
Hello student, so we will continue today module 11, the disposal of solid waste. So in the previous two lectures I talked about the definition of landfill sites and our types of landfill site, the factor affecting site selection, and also in previous lecture I talked about leachate generation followed by treatment. Now today we will talk about gas, that whatever the polluted gas is coming out from the landfill site, how to control and what are the mechanism to produce the gases, different phases of gas production, and also few slides on treatment part. So, is a landfill gas collection and followed by treatment. So, first we will go for landfill gas, that normally called LFG. Okay. Generation mechanism. So, normally the mechanism are by gas generation mechanism and gas transport mechanism. So, there are three major causes of landfill gas generation. First is the volatilization, biological decomposition and chemical reaction. So, one by one we will see that what do you mean by volatilization. So, and what was the different causes of gas production. So, the first is through volatilization. So, organic compound in the landfill will volatile or getting degraded without addition of any kind of microbes, because microbe will grow very easily, whether is a aerobic condition or anaerobic condition, until the equilibrium concentration will reach. So, until that whatever is the volatile substrates are available, whatever the amount, up to until that it will get volatile, these organic compounds, and this process will again accelerated while the biological activity will increase based on the temperature also. So, temperature will also increase, and that is what, if you see the gas production in an entire day, in the night the gas production will be less compared to the daytime, when the temperature reach up to 35 or 40 degree centigrade. So, obviously at this temperature the microbial growth will be very high. So, and very easy for those microbes to volatile the organic compounds, which are very easy for biodegradation. And now this also we can explain by simply by the Henry's law, like mathematically we can explain this by pressure equal to Henry's constant to multiplied by mole function of compound A in the liquid phase in equilibrium with the gas phase. So, likewise we can calculate how much is the gas production could be possible based on the pressure, how much is the pressure normally we will find in the gas phase. Now, this is the first one, volatilization. Next is the biological decomposition. So, this biological decomposition we can easily separate out in the different phases. Normally there are 5 phases. By that way we can easily explain the biological decomposition, or what could be the chemical reaction could be possible, and normally these biological decomposition under the anaerobic condition. So, you already in I think last one module we talked about anaerobic digestion. So, whatever the phases in the anaerobic digestion, almost those phases also you will easily find into the landfill site also. So, based on that you see here and different phases the different gas production. So, normally in the phase 1, which is mostly a aerobic condition, because in the voids the air will be available. So, in that case the nitrogen and oxygen gas. This is nitrogen gas. So, this is nitrogen gas, this is oxygen gas. So, this will be produced very easily, but once it will change into the anaerobic condition. So, slowly the first is the hydrogen production will get start, and after that carbon dioxide will get start. So, if you see the carbon dioxide production and methane production, now in the phase 3 means mostly is a acid phase, where carbon dioxide will be amount will be more compared to the methane one, and finally in the last fourth phase the methane concentration will higher than compared to the carbon dioxide concentration, and last phase fifth phase will be the maturation phase finally, okay, which will go one by one the different phases. The phase 1 is a initial adjustment phase or is a aerobic phase. Okay. So, as I was explaining about that in the voids, because a simple waste has been disposed of, and if you are not compacting that waste, means the initial period especially will be under the aerobic condition only, because in the voids there will not be any degradation. So, in the void also water will not be there in the voids. So, mostly air will be there. So, whatever the degradation could possible in that particular conditions will be the aerobic one, and mostly the gases will produce like nitrogen and oxygen gas will get produced. So, here in the chemical reaction also, if you see, this is a simple glucose kind of or simple volatile matter, organic compounds will get degrade very easily in the aerobic condition. Okay. Now, the next phase is a acidogenesis phase, the same like in the anaerobic digestion, but in the anaerobic digestion for phase 1 will be the first stage will be the hydrolysis and followed by acidogenesis. Now, in this case aerobic phase or initial adjustment phase followed by acidogenesis phase. Now, here the oxygen will be depleted and anaerobic condition begin to develop. So, still in the phase 2 the entire amount will not be under the anaerobic condition clearly. Now, is trying to, because in the voids the because of degradation water will be there. So, slowly is going to the anaerobic condition. So, in that case your pH also of leachate start to drop due to presence of organic acids and elevated level of carbon dioxide. So, in this case same whatever has been produced here will again producing the is a, you see here this is the VFA, volatile fatty acids, okay, but is a mostly the carbon concentration is more into here like is a C2H5 COOH. So, that is in the acidogenesis, means long chain fatty acids will get produced. And you see here, because of that not only the gas production will be different, but also the leachate quality also will get changed. Now, the third phase, that is a acetogenesis phase. Now, is a here the most of these long chain volatile fatty acids will convert into a simple acetic acid. So, here the major gas production will be the CO2, and because of that the pH change or the acidic condition will be more into this one, and the COD and BOD5 value will be maximum in this phase, phase 3. Okay. And if you see the equations also, now this long chain VFA will convert into simple acidic acid. Okay. This is all acidic acid. Now, the fourth phase is a methane fermentation phase. Obviously, once the VFA production will be very high, though later on the methane phase will get start. So, now in this case that whatever the organic acids will as producing, that is acidic acid, and H2 will convert to CH4 and CO2, okay, and pH rise to more neutral value, since the acids are converted to CH4 and CO2, and also nitrogen also will get degrade. slowly. So, ammonia production also will get increased because of pH also will get neutralized. So, in this case you can see that the same acetic acids are converting into the methane and carbon dioxides. Now, the last phase is the maturation phase. So, now is a maturation means most of the biodegradable matter is got degraded, and the rate of landfill gas generation also completely reduced, and but still the principal gases will be the methane and carbon dioxide, and also depending on landfill closure measure, small amount of nitrogen oxygen may also be there. So, this is also, if you see the graph, like in the last phase, fifth phase here, if you see here, here also the small amount of nitrogen and oxygen also you can find it in the last maturation phase. Now, what are the factors affecting landfill gas generation? So, there are number of factors are affecting. When you compare all the factors, the waste composition is the major one, and again and again I am saying that if the waste composition will have more biodegradable fractions or more wet waste, obviously the gas production will be more, and continuously you are getting the more wet waste or biodegradable matters in the landfill site, obviously landfill gas production generation will be very high, and again depend upon the temperature also, because as I was sharing that in the daytime the gas production will be more. These also depend upon the local climatic conditions, like if the normal temperature in a day or night, if it is more than 20 degree or 25 degree, so obviously gas production will be very high. So, is somewhat good also, because your degradation also will finish as early as possible. Otherwise, if atmospheric temperature is below 20 degree, so the degradation won't be that fast. So, even landfill gas production also will be low, and even the entire year also, if you have the similar kind of temperature, the degradation time for entire landfill site will be extended for more time. Also, the moisture pH is very important. So, for moisture I already explained in the last class that that is what I think in the US, this all whatever the leachate is getting produced, that leachate again is getting recirculated, because the upper part of the landfill area is getting dry, and because of dry the microbial growth is not possible, and their degradation also will be very slow. So, the moisture has to be maintained in the landfill site. Similarly, the pH, obviously if pH is getting neutralized easily, so it will go for maturation as early as possible. Local atmospheric condition, landfill cover, cover is also important, because of that only you will be able to get the proper anaerobic condition in the landfill site. Suppose if it is a hybrid conditions in the landfill, like somewhere is a aerobic, somewhere the top area will normally in the aerobic, bottom area will be the anaerobic. So, obviously the gas productions also will be affected for that, and waste density, waste age, this is also very important. Waste density, like if density is more, obviously your degradation will be that won't that very high, but you have to be compact the material. So, obviously the conditions will be anaerobic, more anaerobic could be possible, but anaerobic process normally is a slow process for degradation. And finally, in the waste age, the older the waste, less will be the gas production. Fresh waste, more gas production could be possible. Now, the waste this landfill gas transport mechanism. So, there are two major principal mechanisms, obviously that is in the diffusion and advection. These are two mechanisms. So, the diffusion is obviously is because of concentration. So, obviously, the diffuse flow of gas in the direction which the concentration decrease and concentration of volatile constituents in the landfill gas will almost always be higher than the surrounding atmosphere. So, obviously, the concentration of gas inside landfill is more, it will be higher than the atmospheric condition. So, obviously, whatever gas is getting produced inside the landfill gas, because of diffusion the gas will come out very easily. So, it is because of concentration gradients, and this is also one more, like geomembranes in the landfill covers will significantly reduce the diffusion, because the geomembranes prevent the gases from the diffusion to the atmosphere. Suppose if you do not want to allow the gases to come out through the diffusion, so maybe the geomembranes also will help us. That is why in the geomembranes also are using normally into the landfill liner also, because it is possible that the gases will go into the, could be a water soluble into the leachate. So, and it will go to the groundwater, that is also possible. Now, next is the advection. So, advection is depend upon the pressure. So, the rate of gas movement is generally order of magnitude faster for the advection than for diffusion. So, obviously, the gas will flow from higher pressure to lower pressure, and obviously, inside the landfill material, that waste material, obviously pressure will be more compared to the atmospheric pressure. So, obviously, in the landfill this pressure because of production of vapor from the biodegradation process, chemical reaction, compaction or active landfill extraction system. So, the pressure will be more. So, obviously, that gases will come out easily into the atmosphere. So, these are the two major mechanisms from where the gases are getting generated in the landfill or getting transported from landfill to the atmosphere. Next, the factor affecting these transport mechanisms. So, the first is a permeability. If there is a highly permeable waste, then obviously the whether is a diffusion or whether is a advection will be very fast. If there is a permeability means lot of voids are available, and easily that gas can be come out from the landfill site to the atmosphere. So, normally this coarse grain waste exhibit large values of gas permeability, and more uniform gas flow also could be possible. But normally solid waste is a coarse, obviously the bigger size material, but is not homogeneous material. This is also need to be remember, that is a heterogeneous kind of material. So, there I think, but permeability will be very good, so that gas can be come out very easily. Next is the geological condition. So, this also important, geological must be determined to estimate the potential of for offsite migration of gas, and depth of groundwater. The water table surface act as a non-flow boundary for the gas. So, what I was talking about, the diffusion or advection could not only will possible to the atmosphere, but also into the ground also in the water. So, if there is a water table surface act as a no flow boundary for the gas. During design process, well construct requirement and potential for water table upflowing should be elevated, so that the gas should not be leach out into the water. Next is a man-made feature. It is possible that in some instance like underground utilities such as storm or sanitary sewer is nearby. So, there could be a possible nearby to the landfill area, could be possible to migrate those gases into such areas. Landfill cover and liner system. So, landfill cover system consists of a vegetated surface components or drainage layer and a low permeable layer composed of one or more following like geomembrane, geosynthetics. So, if that landfill cover is a properly with geomembranes or your geosynthetic clay liners, obviously your migrations will be lower down from landfill to the atmosphere. And this another one like barometric pressure. So, in that case like passive landfill gas collection system increase the atmospheric pressure and causes the decrease in gas flow from the landfill, because of pressure difference between the inside and outside has decreased. And in active gas collection system, this is specially with the collection one. So, if passive collection systems if you design, so increase the temperature, atmospheric temperature, so that because of that your advection will be poor in that case. And for active gas collection system like atmosphere air intrusions through the landfill cover during periods when the barometric pressure is rising. If pressure is more, so obviously we can get more amount of gas. Now, here what are the gases, the components or compounds are getting produced in the landfill gas, and what is their impacts. You can see here like carbon dioxide and methane are the maximum percentage, like see the carbon dioxide and methane percentage is a maximum in the, or you can say is the principal gases, but also along with the and you see here their scale of impacts like global and local both, means globally also and locally also could be possible, and type of impact could be global warming is a major one, and relevance are very high, because both gases are greenhouse gases is a problem one. And if you see their expected trend of emissions, so carbon dioxide will be more, the expected trend is more, and from methane is slow, because this methane will produce only in the phase 4 of their degradation. So, the concentration also will be low in that case. But along with that there are other more compounds like aromatic hydrocarbons, like see here pH, this also could be possible. Along with that carbon monoxide, hydrogen, some metals like mercury also will get volatile, and ammonia, nitrogen oxides. And you see here the concentration is not that high, but their health hazard you can see that, or the impact are there, global or local impacts, and the relevance also you can see is somewhat low. That is what the major relevance from the gases like carbon dioxide and methane. Now, when you talk about design of landfill gas systems, so first is a design of gas wells. So, normally we calculate the performance quotient for the well, that is in the meter cube per hour per bar. So, normally the diameter you can see that here you can see diameter, the vertical and horizontal also you can see. And also again we have to see the site contaminants, what are the contaminants are there, like temporary capping we have to provide, that is daily cover, and permanent capping keeping out of water and air, and keep in gases and odors, site lining to contain waste, leachate and gas. And also we have to optimizing the gas well operation, and always you are saying that the gas approaching the well make well diameter large, the large diameter of pipe if you use for gas collection, that will be more beneficial, and even the elevations also should be somewhat good for proper collection of the gas. So, the what should be the maximize the effective length, make gas well deep and keep it dry. If the pipe is deep into the waste and keep it dry, providing some contingency measures like flexible connections, movement joints as well as heads. Now, the design of pipe works. So, pipe specify outside diameter and standard diameter. Normally, we calculate. So, for landfill gas typically pipes are 6 bar and gas flow always gives pressure losses. So, the loss of pressure P for gas flow rate of Q through a smooth pipe of inside diameter estimated using P equal to 60,000 into Q square divided by ID 5. So, this ID is the inside diameter of the pipe and normally we follow this rule, we normally called as a hundredths. That rule means the 100 meter cube per hour of gas flow in 100 mm diameter pipe, 100 mm long pipe gives 6 millibar loss. So, normally we calculated based on these basics. Now, for gas collection system, there could be a passive gas system. So, this passive collection system can be installed during the active operation of landfill or after closure also we can provide. The collection wells are typically constructed of perforated or slotted plastic pipes and are installed vertically throughout the landfill to depth ranging from 50 to 90% of waste thickness. So, even 50 to 90% thickness of the waste we can install the these vertical pipes. It may also include horizontal wells located below the ground surface to serve as conduit for gas movement within the landfill. So, in the bottom also we can put, and also active gas system. So, active gas collection system includes vertical horizontal gas collection well similar to passive collection system. Wells in the active system should have valves to regulate gas flow and serve as a sampling point. So, here this is the vertical one. So, perforated slots, this is normally a plastic pipe, slotted plastic pipe, and now you can see here this is the sampling port also, because time to time we can check what kind of gases are getting generated. Sampling allows the system operator to measure the gas generation, what are the compositions, what pressure, okay, or vacuum or pump to move out of the gas landfill and piping that connects the collection well to the vacuum. So, while in the sampling normally if you find that it is not possible to getting the proper pressure or gas production is low, but you know that the degradation is there, but the gas production is poor. So, we can provide some pump or some vacuum pumps we can provide, so that the gas can be collected by putting some pump. And again the size and type and number of vacuums required in a active system to pull out the gas from the landfill depends on amount of gas being produced. Otherwise, I think that even the pressure has to be fixed properly, otherwise from these openings the water will come out easily. So, how is an effective active gas collection system can be designed? With the following design elements, the gas movement includes vacuum and piping capable of handling the maximum landfill gas generation rate. Collection well placed to capture gas from the all areas of the landfill. The number and spacing between each extraction well depends on waste type, depth, compaction, pressure gradient created by the vacuum, moisture content of the gas. So, again I think is again depend upon the what kind of waste, what kind of depth you are going. Based on that we can provide the number of gas collection pipes and even the spacing between those pipes also we can see that. The ability to monitor and adjust flow from the individual extraction well includes the valve, pressure gauge, condenser, likewise sampling port at each collection well. So, connection of elements of a landfill gas extraction installation. So, these gas extraction well and horizontal pipes can be connected in one or two ways. So, the individual header could be possible. The individual headers required a single pipe running directly from each well to the gas collection system, and most popular pipe is 50 to 63 size pipe, diameter size pipe is very common. So, is a individual header. So, direct there is each and every individual pipe, the directly from that directly gas going to the collection station. This is with the individual header, and with collective headers the gas extraction will link to the several collective headers of 100 to 160 pipe diameter. So, in this case this will be your main collector header, this will be the main one, and from this the gases will come to the main collector header and will gas go to the collection stations finally. And these gas collection stations also, once the entire gas is coming to the gas collection stations, so which comprise the different units like central collector connected to pipe to transmit gas of the landfill, blower to extract gas from the landfill, and after that will be required one small filter to remove the solids could possible to come out, and reservoir to condensate to remove from the gas, and instruments for control of gas extraction and transport, and measuring and control equipments. These are the facilities you required for at gas collection stations. Why are emissions monitored at a landfill? So, landfill gas emissions may be monitored for one or more following reason. For landfill gas control system to determine the general composition and volume over time for air contamination, and emission rates estimated or monitoring may also be used to assess whether it is a technically and economically feasible to recover and use the landfill gas for energy production. This also the important point to monitor the landfill gas. And monitoring of gases that originated from landfill falls into a 5 category. So, the soil gas monitoring, surface gas monitoring, emission monitoring, ambient air monitoring, and indoor air monitoring. So, we will go one by one. Here you can see the monitoring of soil gas, what kind of monitoring descriptions required, and what are the parameters normally we measure into this particular soil gas monitoring phase, and what is the relevance to the public health. So, you can go through this like for emissions, ambient air, and finally for indoor air. Like just a example like indoor air monitoring program measure levels of contamination in indoor air spaces. So, indoor air monitoring of methane is required to structure on many landfill property, like methane monitoring of offsite locations is important to address the site specific concern, and indoor air monitoring data are useful for evaluating risk of explosion and explosion to contaminants within homes. This is regarding to the public health. And there is a other way we can calculate the methane concentration by direct methane measurement. So, there are 3 major methods or different ways we can calculate the direct methane measurement, like flux chamber testing and flume measurement and dispersion modeling. So, in flux chamber this is one of the easiest method. You go to the one particular flux chamber, this you can fabricate any time, very simple. And with this one we can collect how much is the methane is getting produced, that you can check in the laboratory how much is the methane production could possible. So, normally researcher those who are working on to the landfill one and especially our air pollution scientists, they want to know the how much is the gas production could be possible from landfill area. So, they can use this method very easily and can measure the methane concentration. Next is the flume measurements. Flume measurement methods are ground based optical sensor to measure the methane flume coming from the landfill. And the air dispersion modeling also could be possible, can be used for landfill gas. This method monitor on site and downwind methane concentration using dispersion model to calculate methane emission from the landfill. So, now I think once we know that how much is the methane is produced, or if you have the data for 10 years, 15 years for methane production or gas production from the landfill, we can model that, and there are majorly few models are available. Initially started with the zero order decay model, is a simple model where the methane generation we can calculate by mass of solid waste, or how much is the mass is available and how much is the ultimate methane generation potential, that L0. By that way we can calculate, and again this has been modified with the this zero order decay model. Then it has come to the first order decay model. This is the very popular one, which is this also had been used by Environmental Protection Agency US in the LandGEM model, which I am going to discuss. So, is a modified first order model and first order multi-phase decay model. These are the few models are available, and those who are interested to know that how these gas generations are changing with the time or different environmental condition, how the concentration of these gases is possible to change, that we can easily model out. And we have two major models, by that way we can know that how much is the gas emissions could be possible. This is very simple, is a first order decay equation where input parameter is the same, methane potential methane generation capacity L0, and by that way describe for different amount of methane gas potential produced by the metric tons of waste as it decay, and methane generation rate constant K described. And these are the different values are given for ultimate methane potential in the different area, and the K value for that, there is methane generation rate constants, and by that way this model can calculate how much is the gas concentration is possible. There are few assumptions here, like is assumed that waste is a completely homogeneous, that is one assumption has to be there in the LandGEM model, and model does not include categorization of waste. LandGEM assume that waste composition affect L0 and not K. So, likewise there are some limitations of the model. And next is a IPCC model. This is a modified one. The model was developed in the countries to estimate methane emission from waste disposal using regional per capita waste generation rate, population estimates with deduction of landfill gas collection and oxidations. It uses the multi-phase first order decay model, and it incorporates the degradability of waste components and waste compositions while computing the methane generation rate. The input parameters are same, the K value for rapid degrading waste, and our assumptions also is simple. The first approach is to assume degradation of different type of waste dependent or is influenced by each other, and one is a independent. The limitations is also they consider 4 climate categories. So, this most of the model automatically calculate collection efficiency based on answer to the following factors: overall site conditions, waste depth, waste compaction practice, size of tipping area, the bottom liner type, percent of disposal area with operating extraction well, percent of disposal area with daily, intermediate and final cover, evidence of elevated leachate level. I think by these two models you can easily calculate, but again I think I believe that for developing countries like India or other South Asian countries where more amount of biological waste is there. So, there and here also the different kind of biological waste are reaching to the disposal site. So, we need to have special model for us, and our climatic conditions are also different in the entire country are different. Like if you take the example of northeast, where atmospheric condition are completely different than the mainland part of India. So, landfill gas contaminations and their removal. Direct use of collected landfill gas impaired by gas contamination such as hydrogen sulfide, siloxanes and moisture. Landfill gas need to be treated due to its relatively high content of contaminations, and their contaminations are stage 1 and stage 2. The primary treatment consider removal of solids, liquid and gas drying, that is the major one, the treatment one, and the stage 2 desulfurization or organic silicon compounds removal. So, the primary treatment is very simple, to remove the water in the gas particulates. Okay. And siloxane removal, this is in the basic removal, but normally this siloxane removal could be possible by adsorption on activated coal, is one of the easiest method to remove this concentration. And for advanced treatment like desulfurization, like hydrogen sulfide removal could possible, and there are different methods you can see, like biological desulfurization, water washing, activated carbon is also method to treat these gases. And some more like other gas pollutants could be ammonia, halogens or aromatic hydrocarbons could be possible, and there are number of contaminants are there, but their concentration very below to the detection level also. Now, energy technology, the major energy, whatever gas is purified gas is a combustible gas, consists of methane and hydrogen. So, boiler technology is most common technology to produce energy out of that, or direct thermal application, which includes kiln, sludge drying. Directly we can use this gas for the energy production. Biomethane production also is possible, because the major gas concentration is methane, hydrogen, carbon dioxide. If you are able to remove this or separate out this carbon dioxide and methane, like same in the anaerobic digestion process also, we can get proper biomethane production could be possible, and this CO2 removal also could be possible by different methods like membrane separation, and other techniques are available for that. So, these are the different methods, by that way we can remove the carbon dioxide from the gas to get the proper biomethane. What are the reasons for landfill gas control? There are following reasons, like prevent air pollution and comply with regulatory air emission criteria, reduce hazard due to the off-site migration, prevent damage to the landfill cover slope stability, odor control, and also energy recovery is possible. So, you see here as in conclusion that the gas collection not only is a difficult task, but also the treatment is also another difficult task in this particular for the treatment of these landfill gases. So, again I am saying the same thought. The major production is a volatilization and biological decomposition. That is the major cause of this gas production. So, if you are not allowing the biological waste to enter into the landfill area, then there will not be any volatilization, there will not be any biological decomposition. So, your gas generation also will be very low. So, you need not to worry much, and because the gas concentration is low, means your what the major mechanisms like diffusion and advection, that will be also very poor. So, very small concentration of gas will come up. This odor issue will be always there, because methane is also odorous gas, and along with that the ammonia, hydrogen sulfide production, this is always there. But that concentration also very poor if you are not allowing the biological material to enter into the landfill area. And is not only the landfill gas production will be very low, but also the leachate production also will be very poor in that case. So, see, saying that we have the sanitary landfill is available with us, you will be required very skilled manpower to collect the leachate and gas, followed by treatment process, will be required lot of money, lot of fund is required for running such kind of facilities, and there is no income from this kind of facility. So, rather than working for the again I am proposing that rather than working for landfill or to get the sanitary landfill for us, you need to more focus on to the treatment facilities like biological treatment facility. We can put lot of fund onto that. Why not you propose more recycling, more even the incineration facility? The capital cost will be very high, but I think you need not to work into the landfill area, because this is in the open area, the landfill, and is highly affected by the local conditions, and we can't change the local conditions or atmospheric conditions. We have to work along with the local conditions, and difficult to work. So, here we are finishing the complete landfilling one, but next lecture I was thinking about to have some examples or some numericals will solve, and also here is very important to talk about legacy waste or the old landfills. Suppose Indore has come up with new sanitary landfill, but before that they have to remove out the old landfill, or we can say they have to biomine or bioremediation has to do in that site. So, that we will talk in the next lecture. Thank you.